This is a revision session for OCR FP1. The topic is matrices, and we're doing January 2010, question 9. So in question 9, it tells us that the matrix A is given by these numbers, a 3 by 3 matrix, and importantly it does tell us that little a here, the entry in the third row and the third column, cannot be equal to 1. So what we're asked to do is first of all find the inverse of this 3 by 3 matrix, and then in part 2 it says hence or otherwise solve these equations. So you have a set of simultaneous equations. Now when it says hence or otherwise, generally speaking, hence will be quicker. And if you notice, of course, that the coefficients of x, y and z in these three equations are given by the entries in the matrix, then that is the way we're going to do it. So let's have a look then at this first part where we're asked to find the inverse of A. So in order to find the inverse of matrix, the first thing you always ought to check first is the determinant. Because of course if the determinant is equal to 0, then your matrix is singular and it's not possible to find the inverse. So we'll start by finding the determinant. So the determinant of a matrix can be found by expanding either a row or a column. Now because the first column has a 0 entry in it, I'm going to expand by the first column. So what that actually means is that I am going to find the cofactors of each of the elements in this first column, and cofactors are minors with the sign attached to them, and you ought to know that there is a matrix of signs attached. So I'm just reminding you there what I mean by the matrix of signs. So the cofactor, for example, of 2 is going to be the matrix, the 2 by 2 matrix that you get when you cross out the first row and the first column. So it is going to be this 2 by 2 matrix here, and its determinant is 3a minus 1. And it will be positive because it's the first element. The next one is going to be negative, but then of course we would be multiplying by 0, so that doesn't count. And then the next element is going to be positive, looking at this, so it's going to be plus 1. And now we're crossing out the third column, the third row and the first column, and we're left with minus 1 times 1, which is minus 1, minus 1 times 3, which is 3. And so if we simplify that, we end up with 6a minus 2 minus 4, so 6a minus 6. So that is the determinant. So notice why a cannot be equal to 1, because of course if a was equal to 1, then our determinant would be 0. So once we've found the determinant and it's not equal to 0, we know we can find the inverse. So what we need to do is we now need to find the matrix of cofactors. And the matrix of cofactors is then the rows and columns are interchanged to find the adjoint matrix, and then we need to multiply that by 1 over the determinant. So let's find the cofactors. So the cofactor A11, that means that we're taking the 2, so we're referring to this element here, we're finding the cofactor of 2. So we've already done that in a way, because when we were finding the determinant. So the cofactor of 2 is going to be 3a minus 1, and it's going to be positive, simply because of our matrix of signs. And then I'm going to find the cofactor of A12, so that's this next one, But I'm going to write it down here because I am going. It's by putting it underneath, then if you like, I'm transferring, forming the rows into columns. So A12 means you're crossing out the first row and the first column, so it's going to be 0 times A minus 1 times 1. And of course, because of the matrix of signs, it is going to be minus 1. And then I'm going to find the next one, which is A13, but I'm transforming my rows into columns, so I'm going to write it underneath. And A13, so we're crossing out the first row and the third column, so it's 0 minus 3, and of course it is positive 0 minus 3, so that's minus 3. And we go through and do the same now for the second row. So in the second row, you're now taking this 0 and the cofactor of 0, so it's going to be minus A minus 1, and the sign attached to it is a minus. So let's just check on that. So 2, 1, so it's going to be minus A minus 1. And then A2, 2, just going through the same, is going to be positive, and it's 2A minus 1. A2, 3 is going to be negative, and A2, 3 means we're crossing out the second row and the third column, so it's definitely just going to be 3. And then we'll do the same thing for the third row. So A3, 1, so we're crossing out that third row and the first column, so it's going to be positive, because we're going back to the matrix of signs up here, so it's going to be minus 1 minus another 3, which is minus 4. And again, if we work through and find A3, 2 and A3, 3, this will be negative and this will be positive, and then we'll just work out the minors, and that is 2 and this is 6. So what I've actually done here, by writing them down, this was the first row of cofactors, but I wrote it down as a column. This was the second row of cofactors, but I wrote it down as a column, and the same for the third row. It then means we can write down our inverse. So 1 over the determinant, which was 6A minus 6, and we then have 3A minus 1, 1 minus 3, A plus 1, 2A minus 1, and minus 3, and then our third column will be minus 4, minus 2, plus 6. And that is the inverse of our matrix. Now, if I have a wee look at how we award marks for this, then you got 3 marks for the determinant. You got 1 method mark for the correct expansion process. So there was a method mark over here for expanding it. There was another method mark for getting at least 1 of these 2 by 2 determinants sorted, so I'll put another M1 there, and there was an accuracy mark for getting the correct determinant. So 3 marks for the determinant, and then for the inverse of the matrix there was a mark for the process. So a method mark for using the right sort of process. There was an accuracy mark for at least 4 correct entries. and then there was a mark given for dividing by the determinant, just a B mark, and then there was an accuracy mark, A1 mark, for completely correct, all correct. So 7 marks for finding the inverse. So it is a process you need to be able to do with confidence. So we now look at part 2, and it said hence or otherwise solve these equations. And as I say, we're going to use hence. We're going to use the fact that we have the inverse of the matrix. So if you look at those, as I said before, we can see that actually we can write those simultaneous equations in the form of 2 minus 1, 1, 0, 3, 1, 1, 1a. That's just taking the coefficients of x, y and z, and that is equal to 1, 2, 2. Now of course you'll notice this was the matrix that we were given in part 1, so that's the same matrix. So all we have to do is to multiply both sides of this expression by the inverse. And of course when we multiply this matrix A by its inverse, we get the identity. So we can say that x, y, z is equal to, now the inverse was 1 over 6 minus 6a minus 6, lots of, and it was quite sort of complicated. It was 3a minus 1, 1 minus 3, a plus 1, 2a minus 1, and this just comes from the answer that we had to the first part, and the last column was minus 2, minus 4 minus 2, 6, so we'll multiply that by 1, 2, 2. And if you multiply that out, you'll end up with, and just be careful, but you're multiplying the first row into this column, so that's going to be 3a minus 1 plus 2a plus 2, because you're multiplying the a plus 1 by that 2, and then minus 4 times 2, which is minus 8. And if we do the same for the second and the third row, we'll get, the second is 1 plus 4a minus 2 minus 4, and the third will be minus 3 minus 6 plus 12. So it looks a little bit messy at this stage, but actually you can simplify that now, and you get 3a plus 2a, so 5a, minus 1 plus 2 is plus 1 minus 8, so 5a minus 7, 1 minus 2 minus 4, so that's minus 5, and you've got a 4a, so 4a minus 5, and then minus 3 minus 12, 6 plus 12 is 3. So that is our answer. And again, there were 4 marks for that question. So if we just look at how they've been awarded, then there's M1 for a correct attempt at this idea of multiplying by the inverse, so this a minus 1. So multiplying by that, if you do, as long as you attempt that correctly, you will get a method mark. Then there was an accuracy mark for each of these answers here. So you got 1 for each. What was a 1 there? So 1 mark for each of those. So 4 marks in total. So just remember that if you do want to look at any other questions or revision questions from any of FP1, then all you need to do is go to the Further Maths website, and that will take you there.